Look up at the stars tonight and realize you are looking at a beautiful, glittering prison. For all of human history, we have gazed at the Milky Way with a sense of wonder. But the cold, scientific truth is that we are likely trapped within its spiral arms, separated from our nearest neighbor, the Andromeda galaxy, by a staggering 2.5 million light-years of empty, hostile void. Even if we could board a spacecraft traveling at 28,000 kilometers per hour, it would take us nearly 95 billion years to reach the next galaxy. A span of time so vast that the stars themselves would burn out before we even finished the first leg of our journey. And even at the speed of light, the cosmic speed limit of the universe, the trip would take 25,000 human lifetimes, making the dream of galactic migration seem like a mathematical impossibility. But what if there was a crack in the code of the cosmos, a secret back door that allowed us to bypass the tyranny of distance and step across the universe as easily as crossing a street? This isn't just the plot of a science fiction movie like Interstellar, it is a serious prediction buried within Albert Einstein's 1915 field equations, a set of 10 complex mathematical descriptions of how gravity, matter, and energy warp the very fabric of reality. Einstein, along with his assistant Nathan Rosen, theorized that space-time isn't a static void, but a flexible, physical mesh that can be bent, stretched, and even folded upon itself to create what we now call an Einstein-Rosen bridge, or a wormhole. To visualize this, imagine the universe as a flat sheet of paper with point A on one side and point B on the other. In a three-dimensional world, the shortest distance is a straight line. But if you can fold that paper until point A and point B are touching and then punch a hole through them, you have created a shortcut that reduces millions of light years to a matter of meters. However, the physics of actually building or finding such a bridge are terrifying because to warp space-time that severely, you would need a gravitational force so intense that only a black hole could provide it, an entrance so violent that it crushes light itself into a single, infinite point of density called a singularity. Yet, a black hole is a one-way street, a cosmic trap from which nothing escapes, which has led physicists to hypothesize the existence of its mirror image. The white hole, a theoretical region of space that is the exact opposite of a black hole, where nothing can enter but everything must exit, spewing light and matter into a distant part of the universe. If a wormhole exists, it would be the tunnel connecting these two monsters, a black hole for an entrance and a white hole for an exit, creating a gravitational corridor that could theoretically allow a human being to witness the birth of stars in a different galaxy and return home for dinner. But the challenges are monumental. Even if we found a wormhole, we suspect they are naturally unstable, snapping shut in a fraction of a second unless held open by exotic matter with negative energy density, a substance that defies our current understanding of the periodic table. While we haven't seen a gravitational wormhole in the deep dark of space yet, scientists have already successfully created magnetic wormholes in laboratories, using superconducting materials to funnel magnetic fields through an invisible gap, proving that the geometry of shortcuts is physically possible. And if wormholes fail us, we still have the Alcubierre drive, a theoretical warp engine that wouldn't move a ship through space, but would instead move space around the ship, contracting the universe in front of it and expanding it behind it, allowing us to surf on a wave of warped reality at speeds that make light look like it's standing still. We are currently a species confined to a single pale blue dot, but the math of the universe suggests that the Milky Way isn't our final destination. It's just the lobby of a much larger house, and as we learn to navigate the curves and folds of Einstein's equations, we may one day find that the stars aren't out of reach, they're just waiting for us to find the right door. We are a species of explorers, and if the laws of physics have left us a shortcut, you can be certain that one day we will have the courage to take it, stepping out of the Milky Way and into the infinite expanse of the multiverse, transforming from planetary dwellers into truly galactic citizens. This is the ultimate frontier. The moment humanity stops being a passenger on a rock and starts becoming the architect of its own cosmic destiny, proving that while the universe is unimaginably big, the human imagination is just a little bit bigger.